Good morning, everyone. I'd like to welcome you to our FYRE Weekly Wednesday webinar, sponsored by Newfields Ag, where we bring innovations in your fields. We encourage you to visit our full-service website at newfieldsag.com, where you'll find a complete listing of Newfields Ag products, product descriptions and videos, use and application instructions, contact information for your local dealer, pricing, and much, much more. Thanks to each of you for registering and joining us today, and if you have any questions during the presentation, please place your questions in the chat box or simply raise your hand and we'll get it asked. I'm your host, Brian Tully. I appreciate you being with us today. And today we get a chance to visit with Ms. Robin Ross, and she's going to focus on nitrogen efficiency in plants and the nutrient use efficiency in crops, primarily focused around the use of biologies to get that done. Robin is with AgNexus. She's a researcher and has worked with several companies that we're working with as well in researching products, and you will see some of the products that we have in Newfields Ag show up in some of our research here over the last couple of years. Robin comes to us with a master's degree in plant pathology and a minor in experimental statistics from Clemson University. So I told her before we started we'll talk slow so she can understand us.
Thanks.
Robin, welcome. Thank you for joining us on this meeting, and we have an interested group of people here, and there'll be some questions come up, and I'll interrupt you as we go forward. So thank you very much, and I look forward to hearing what you have to present. Thanks, Robin.
Okay, let me share my screen. I'm going to turn off my video while I'm sharing my screen. Okay, can you guys see my screen?
Yes, ma'am.
All right, so yeah, I'm going to jump right into this. What I want to focus on is using biology to enhance nitrogen efficiencies in your crop. Regardless of the rate of nitrogen that you're using, how do you make sure that you're getting all of it into the plant and all of it is moving towards the best yields you can possibly get? So I want to start with one of the trials that I did this past year using biology and technology called Low-Mu-Tech that I believe y'all are familiar with. This trial was done in Wisconsin by Dr. Tim Maloney, and here the treatments included just a talc graphite seed lubricant, so this had no biology in it at all. And then I put in a talc graphite seed lubricant, applied at the recommended rate, and then added a nitrogen fixing consortia. This consortia is kind of interesting because it's composed of endospores, which are super strong spores that are resilient to the talc graphite, but also any of your in-furrow fertility, anything else you might want to put out there. These spores are very resistant. So it's a unique consortia of microbes. And then I did the same thing using Low-Mu-Tech and then used that exact same consortia. I was kind of thinking this Low-Mu-Tech, talc graphite can be kind of toxic to biology. Low-Mu-Tech should act almost like a seed, like a food source to the biology. So I thought this would be a really interesting way to look at this. So this is the percent emergence over time. If you look at the lines here, the light blue line here is just talc graphite with no biology. The dark blue line is talc graphite with a nitrogen fixing biology. And the orange is Low-Mu-Tech with biology. Across my x-axis is from VE, so when the plants first just started coming up, all the way out to 21 days. So we've gotten to full emergence there. And my y-axis is percent emergence. So the first thing I think you're going to notice is adding biology certainly caused faster, stronger emergence. That's these two lines right here that include a biology, whether it's talc graphite or Low-Mu-Tech. The one sitting up here at the top, though, that tended to be better all through the season was the Low-Mu-Tech. I would suggest that it's exactly like I was hypothesizing, that adding something like Low-Mu-Tech as a food source to this nitrogen fixing consortia caused that plant to come up more vigorous, stronger. That has a lot of benefits because, I mean, a lot of people will say, well, how fast your crop comes up directly plays into yield. I think that's true, getting a strong start. Also, when it's cool and it's wet, it's, fall, those seedlings that are not vigorous are more vulnerable to any kind of damping off pathogen or just any kind of trouble. The quicker you can get those plants up out of the ground, the better off you're going to be. And I think adding a seed lubricant, adding biology especially, was what helped. Here's final stand. When you finally got all the way out to here, that would be this data right here. That's at V4. Adding biology even improved final stand. You can hypothesize, well, why'd that happen? I would suggest it may have something to do with just damping off, stronger just seed emergence in general. So I was also interested in, does this Lomutech really even work? How does this work as compared to talc graphite and making sure the seeds are coming out of the planter in a uniform way? And so all I did was took all 6 replicates of the trial and had the researcher go out there and measure them, knowing his planter was set at 2.4 inches. So he went out there and he measured it and said, well, what's my distance between plants? This is my control that just had talc graphite. And you can see there's a pretty wide variation. Some of that could have been because you'd be like, well, why does biology help with this? I would say that some began to damp off. You have a bigger space here. Maybe you were missing a plant or something like that is what caused some of that variation. This is talc graphite with biology. The seed spacing is a little more consistent. And then when you've used Lomutech, it's far more consistent. So I think what we're looking at here is a mixture of the plants are hitting the ground, growing, less damping off, and also the seed lubricant itself is dropping them at a very consistent space, especially the Lomutech. Another way you can look at this is simply calculate the standard deviation between this distance. The lower the number, the better. That means the less variation there is in how your seeds dropped, or at V4, V3, the less variation you have in stand. I say that because I think it's more than just the seed dropping. It's the seed dropping and everything emerging and growing. So it's both combined. Here's our talc graphite alone that had the greatest standard deviation. That means there's more deviation in the distance between the plants, or is there even a plant there? Talc graphite certainly helps if you have biology in there. Lomutech was our best treatment here with the most uniform plant spacing at V3, V4. So let's look at vigor over time. This is rated on a 0 to 10 scale. That's my y-axis. This is time on my x-axis. I'll just start at V emergence. VE, you can see that the 2 that have biology emerged the quickest. As time goes on towards 21 days after emergence, the one that had the Lomutech was consistently the most vigorous. And y'all know that early season vigor, get that crop established, get it growing, is extremely important. A lot of parts during the season too, this was statistically better than talc graphite plus biology. So the Lomutech with the soybean protein actually can serve as a food source and even amplify the effects of having biology in the system. By the time you got out here to 21 days after emergence, there were no more statistical differences here in vigor. You couldn't see it anymore. But nonetheless, I think even early on, coming out of the ground strong has a huge benefit.
Robin, this is Brian. A quick question on that.
Sure.
When does the biology that you included in this test become plant available?
It's going to take a couple of days for it to come out of that endospore. An endospore is, like I say, a very firm spore that is almost impervious to fertilizers, chemicals, and things like that. But once it perceives it's in a nice moist environment, it's going to perceive, oh, I have a host here. That would be your seed and your roots. It'll start to grow pretty quick. I would give it a few days. So quickly.
Do you think it falls within that the VE4, VE7 in that time period is when it would start showing, and that's why you see that the graphite starts catching up with the dust at that point?
It's hard to say. I think by here, because you see such a big difference right here, I think the biology is actually working synergistically with the Lomutech product. I think it's perceiving that as a food source and a better home, a better place to be, and it's causing it to germinate and establish more quickly. So I think it's working synergistically with the biology.
Great, thank you.
I would guess that, you know, he's rating vigor on a 0 to 10 scale. By the time he's at 21 days after emergence, these plants are getting a little bit bigger and it's harder to see minute differences. I think some of that's just Tim Maloney's ability to visually rate that at this point. Yeah. All right. And then if you look at yield per acre, how did all that come together? The biology that fixes nitrogen, the seed lubricant that makes sure that the seeds are dropping in the right place, and the seed lubricant that actually can serve as a food source to the biology. And that seed lubricant may, in some weird way, serve as a food source or maybe even have some growth effects even on the seed itself. Well, our lowest yielding treatment was the talc graphite alone. You can see that's statistically different from low mutec plus biology. So those two are different. If you look at talc graphite, if you add biology, it's numerically better than the talc graphite control, not statistically different. So there really is something here about using this type of seed lubricant if you're choosing to put biology in there with it. I think there is a synergistic effect there. Probably deserves a little bit more research to understand exactly the nature of it, but the easiest example or the easiest solution or way to describe it would be it's almost like a food source, or at the very least not toxic. Talc graphite very likely might have some negative effects on biology. If you're going to spend the money on your biology, let's give it every chance. Give it every chance. All right, so let's talk about corn and some even more complex trial work. So what I wanted to do here was look at a nitrogen fixing consortia in corn. I wanted to look at kind of this new thing of, can you pull nitrogen from the air? Can you use endophytes that are foliar to actually supplement the nitrogen levels in the plant and improve yields simply by pulling nitrogen from the air? That sounds like an amazing concept. But if you really start thinking about it, biology never stands alone. Biology lives in harmony with the crop. Biology has to live in harmony with the other microbes that are there. It's all one big like ecosystem. So what I did was looked at a nitrogen fixing consortia. So this is not just a single strain of nitrogen fixing microbes. It's a consortia that contains microbes that are going to be happy on the leaves and do that job of fixing nitrogen from the air. Microbes that are going to be happy living around the roots and fixing nitrogen. That's not described very often in corn, but it does happen. Microbes that might excrete certain kinds of things that other microbes want to eat, and microbes that even kind of work towards nitrogen cycling to constantly be breaking down organic matter in the soil and provide nitrogen to that crop through just composting or nitrogen cycling. So I looked at a consortia that does exactly that right here, and there I just put it in furrow at planting. My idea though was, if you have a foliar endophyte in there and you wait until, let's say, the V3 or V4 to go out there and apply it, that's somewhat limiting, because ideally your foliar endophytes start to establish as the seed germinates. It gets all over the germinating plant as it's coming out of the ground. It's in the whirl of the corn as the corn starts to push out new leaves, and you've got biology there the entire time. And the consortia that I used was designed to do that. So I was testing it against Invita. This is by Azotics, because that one kind of comes at it with the idea of, let's just apply this foliar. This is a foliar endophyte, so let's make it foliar. So I was looking at two situations. Here's my biology. I applied it in furrow. I know it's going to fix nitrogen in the ground, but I also thought this has an endophyte in there. It's going to get on the emerging plant and maybe start improving yield from the very beginning. And then I looked at that same consortia. I put it in furrow, and then I made another foliar treatment of that exact same consortia at V3, V4. I compared that to using the nitrogen fixing consortia in furrow, and then let me put Azotics Invita out there because that's one that's a lot more known for being a foliar endophyte and fixing nitrogens. This one had more microbes in there that actually also work in the soil. And I'm like, maybe I should put these that have all these great soil microbes plus an endophyte. And maybe this endophyte Invita is a little bit better, a little bit stronger. Let's see how that works. I looked at Invita by itself, applied foliar, and I looked at this soil biology consortia, nitrogen fixing consortia foliar by itself. I also put a food source in there. This food source has folic acid, some glycine betaines, a few plant extracts, things like that. It is a company's private labeled product that they use as a food source. I think you could probably use anything you wanted. My whole goal with adding a food source there was if you want the biology to grow and you're putting a seed in the ground, it needs something to live on or some reason to grow before those roots are there, or it's going to sit there and not be very happy because it doesn't have a home. So that food source kind of causes the spores to germinate and causes the biology to stay alive until it can get on those roots and be in that synergistic environment. Consider too, because I did put it in there with these foliar treatments, that's a harsh environment for a microbe to spray it on the leaves, and it's just going to sit there and bake in the sun, or it's going to be super cold or super hot. You don't know what it's going to be, and adding that food source, I think, improves the chances of those microbes to survive even on the leaves. So there was a food source included with all biology treatments. Okay, let's look at stand over time, and I left off the foliar treatments because they're not applied yet. Again, my x-axis is from emergence all the way out to final stand, which was 21 days after emergence. So it's expressed in percent. The first thing you'll see is anything that had biology in it. That's, oh, I forgot to tell you one key thing. I looked at it at two different fertility levels. What I thought would be a full fertility and then a slightly reduced fertility. The fertilizer I used is 10-10-10. I know that might not be exactly normal, but what I was looking for was to reduce NP and K so that we kind of had an overall deficiency in this reduced fertility treatment, because some of these microbes help with a lot of other things besides just nitrogen, even though that's not necessarily what's claimed on the label. Microbes are key players in solubilizing phosphorus, cycling potassium, and other effects too. So that was my two fertility levels. All right. So my two blue ones here are standard fertility, the light blue just fertilizer, 225 pounds of nitrogen per acre. The dark blue is standard fertility plus biology plus that food source. Here is the reduced fertility treatments. So the first thing you're going to see here is that adding the biology, again, popped them out of the ground faster. That held true at V2, emergence plus 2 days, emergence plus 4 days. It's still statistically significant all the way up to final stand now. Even though these differences are not quite as visual, there was still better emergence overall by including biology in the soil. Note that Invita has not been applied yet, so that has nothing to do with this data because that's a foliar product. This is just the effect of biology applied in the soil. At this stage too, there's really no particular difference in stand between how much fertilizer was put out in the field overall. You would expect that. It's too early in the season for stuff like that to show up yet. This is plant vigor, a visual on a 0 to 10 scale. Again, adding biology improved plant vigor. So we're also kind of back to that same story of get your crop out of the ground and get this thing growing. Biology definitely seems to add to that. And again, there's no real differences between the amount of background fertilizer at this early stage, just 7 days after emergence. You can't see that there. NDVI was taken 7 days after V4 and then 34 days after V4. That's my x-axis here. NDVI is a way of kind of estimating biomass. I'm going to put my glasses on to look at this chart. If you look at how this is set up, this group of data right here is at full fertility. This group of data right here is the lower fertility. And you can start to see that at this stage, the background fertility doesn't matter that much when you're at V4 plus 7. Now when we're 34 days after V4, now you start seeing the lower background fertility general vigor is starting to drop off. The best treatments in here, though, that would be this orange bar at full fertility. That's just making sure that you're adding biology in furrow. And now there's this foliar treatment here of the nitrogen fixing consortia. This treatment right here is this standard fertility plus biology, and this was applied in furrow, and it has Invita in there. Somehow or another, my key here is missing that word, but Invita was also applied. So those look very good. Even when you're at a lower fertility, those two are still statistically the best treatments. So in furrow plus a follow-up treatment, foliar at V3, V4. But when you start getting out here 34 days after treatment, after V4, now my best treatment here is this orange one. Statistically, these two are kind of similar to it, though. That's that nitrogen fixing consortia in furrow plus the same one applied again foliar. Look over here if you are just using foliar treatments. Here's the Invita right here. It had nothing in furrow. Here is the nitrogen fixing consortia applied only foliar with nothing in furrow. You can see they don't look quite as good. Compare those to these two treatments where there is an in furrow treatment. So I think there's something to be said for trying to start it out right and then apply another treatment at V3, V4. Look at the reduced fertility though. Here's my two foliar treatments with nothing in furrow. I think that it looks much better once again to have a in furrow treatment as well. If you count the numbers of kernels down the length of the ear, this was done almost at harvest. What I'm seeing here is that adding biology seems to possibly be improving pollination because there's more kernels down the length of the ear. That could be to do with biology can sometimes actually be causing some biostimulant types effects that cause the crop to be able to handle stress a little bit better. By handling stress better, that may improve pollination, or there could have been more vigor in general, and even just throwing off the day that the crop pollinates by a day or two can sometimes improve pollination or change the numbers of kernels down the length of the ear. So you would have less of a nose. Or maybe it's a biology stress. You know, it has nothing to do with any biostimulant effects. It's just that there's a nitrogen stress there and biology seems to be helping. But certainly adding biology is improving pollination here. This is total numbers of kernels per ear. See the same thing, especially at full fertility. Here's my two foliar treatments. They don't look as good as when you have that in furrow. Then if you looked at reduced fertility, similar effects, but the crop is struggling a little bit more. So you do have less kernels per ear. You can see reducing that fertility is going to be probably impacting yield. Note too, let's look at this one, this green one as compared to Invita. Statistically, at full fertility, there's more kernels per ear with this nitrogen fixing consortia as compared to Invita. The same is true over here. So there's something going on that might be better to add an entire consortia of nitrogen fixing microbes, even though maybe only one or two are the ones that are actually fixing the nitrogen. The other microbes that are associated with that consortia support the microbe that's doing the hard work. And then if you look at yield per acre, okay, here's my standard fertility. My best yielding treatment was the consortia applied in furrow, and then once again foliar at V3, V4, yielding 232 bushels per acre compared to 218. If you go over here and you look at what about our two foliar treatments, where we left off that in furrow treatment, this is pretty close. Just adding that foliar treatment was actually statistically better than this corresponding control. Although adding the in furrow treatment was statistically better. It's got an A there as compared to just the foliar treatment. Invita looked good. Statistically, though, it was not different from the corresponding control there. They both have a C. If you start looking at reduced fertility, Best treatment is the same one. Use the consortia in furrow and then do it foliar. That is statistically better than the corresponding control. But take a look at this. This is AB, and compare that all the way over here to this control. This is the control that had no biology, but it's at a full, 225 pounds of nitrogen per acre. This is statistically better. So it really is allowing this crop to yield even better than this. It's compensating for that lack of nitrogen. These foliar treatments, they are statistically similar to this control. I tried to think about, why is this the best treatment? Because our focus here really is this an endophyte. Both this biology here does contain a foliar endophyte, and that's one of the main strengths of this. So what is it here about putting it in furrow and then also applying it foliar? The traditional thinking has always been, if you have a foliar endophyte, put it foliar. And yes, that's true. But I think that there's a lot to be said for the strategy of putting it all together in a supportive consortia of microbes and getting that endophyte established from the moment that the corn pushes out of the ground, and going with the hypothesis that that consortia is going to be all in the world. And with every leaf that's coming out, it's basically inoculating all of those leaves as they grow. I think that's a great strategy. This probably deserves a little bit more research, but I do believe that's why this treatment is looking better than either of these two, where Invita or this, a biological consortia that also contains a nitrogen fixer is only applied foliar. So it's kind of turning the whole idea of these foliar nitrogen fixings on its ear, where, well, it's more complicated maybe than just spray it out like a foliar nutrient. Has been kind of our mindset over the years. I think it is more complicated with it, and it's trying to work out the nuances of biology.
Robin, Brian again here. The question is the application timing, and then the word consortia that you're using as we move in to talk about this as well. That consortia, is it considered a consortia when it's applied all at the same time? Or is it considered a consortia if you have some in the ground and then you come back and you add additional through a different application method? And so can you see a multiplying effect by, your data is not showing that, that is showing that we can see obviously some follow-up with that. But do you see that all the time? That if you do something that is a biology down with the seed, and you come back with one as a later application, foliar being V3 or even at VT, are you seeing a difference with that as you look at your research on this too?
Yeah, well, to begin with, let me define consortia. That's like a whole bunch of us hanging out. A consortia is like a gaggle of friends or something like that, a whole bunch of us that want to hang out together. And so a consortia means it's a bunch of microbes all in one mixture, that all are supportive and friendly with each other and perform supportive functions. And so that's what I mean by consortia. So they're in the package all together. It's not talking about, I put this microbe early and this microbe late. This was the exact same group of friends applied either in furrow foliar or in furrow plus foliar. As for the second part of your question, I would say that the idea of using nitrogen fixing microbes is probably an idea that's only been out there commercially in people's minds for a couple of years. There's some that people are putting in furrow, and then there's some that people are applying foliar. A couple of years isn't very long in our, big world of agriculture, and biology is a very new thing. This idea of putting biology on leaves is an even newer thing. So I can't say for sure, but I think we are uncovering the best way to use these kinds of products. Take note, for example, that even Invita, this is marketed as a foliar product, but look at Invita. If you look at it right here, it's got a nitrogen fixing consortia applied at planting plus foliar. Here it is it's only Envita applied foliar. So supporting it from the very beginning and then following up with that foliar, I think is proving out, regardless of which consortia you want to use. Well, Envita, I think it might be a single strain, but regardless of which biology you're using, this is looking better than this. This is the consortia in the soil plus foliar looks better than this. So I think the 1-2 punch, I might be a little ahead of my time because I don't think it's super proven, but I think it makes sense. And this data absolutely supports that. Even at reduced fertility, this treatment is better than this treatment. That's the Envita foliar, or should I maybe put a supportive consortia in at planting? Put it at planting, that looks better. Or this treatment looks better than this treatment. So, even if it's a different consortia, it looks better with a 1-2 punch. This also, is statistically better. It's not just, I think it's better. This is statistically better than this. So, yeah, Brian, I like your question because it shows you're thinking and really thinking about what is the best way to do this. I think we're all learning, and I think we're on the right track with this.
Well, that's what I appreciate. I appreciate what your data is showing here, because that's what we've been talking about as you talk about with this new field of the biological side of this, is that it is a system approach, right? And every crop, every region of the country is going to be a little different as well. And then, what you're bringing forward here is the fact that, the biology does have a response. And then how do we manage that as we go through the whole growing season? So, yeah, I appreciate that.
Yeah, I think one of the biggest issues we have with biology is because it's very new, we haven't known the best way to optimize that. And then, we went out there with every good intention at times, and then it just didn't look as good as we wanted it to look. Here's a great example. What if you're at good fertility, here's your yield in the control of 218 bushels per acre, and here it is just using Envita of 219. Does that mean there's a problem with Envita? I don't think so. I think Envita does fix nitrogen. It's learning how to optimize that. And I think that will be more complex. And it's going to play into how good are your people there that can understand those nuances and make those good recommendations.
Thank you. Yeah, we agree with that 100%. And to have the conversation individually rather than trying to make a broadcast application across the industry of what to do. So thank you.
So I tried to look at this a different way and say, well, all right, sometimes people think about how many bushels of corn can I produce per pound of nitrogen that I'm putting in the ground? And the standard concept has been maybe, a pound of nitrogen for a bushel of corn. So if I base that on, 225 pounds of nitrogen, how many bushels of corn can I make per pound of nitrogen under this circumstance? If you don't do anything else, no biology, you're producing almost a bushel, 0.97. That's pretty close. Our thinking has been right. But what this is showing is that by adding biology, even under a full fertility regime, you're kind of optimizing that such that you're getting maybe a little bit more than 1 bushel of corn per pound of nitrogen used. So you're improving your efficiencies. And I think we're going to get better and better at this, where we can do it little by little by little. We'll continue to improve those efficiencies. If you look over here at reduced fertility, that's not surprising me at all that it looks like it's more efficient. We're making that plant work a little bit harder. Overall yields were lower when you start reducing fertility, but nonetheless, it's having to work a little bit harder and can produce a little bit more bushels per corn per pound of nitrogen. Even in that scenario, biology now starts to really shine, because I think it does work in synergy with the crop to help optimize the way nitrogen is taken up and the way that it's actually used and used to produce yield. So either way,
Robin,
yeah, go ahead.
The other thing this could be pointing out is that nitrogen is not your limiting factor.
I think you might be right.
Because the reason that we like the consortia that you're talking about is because of that very thing, like you've been talking about all along, that it works as a group, right? And that whenever you look at a single strain of that, you're hoping you hit it at the sweet spot and you see a response. But what if that's not your limiting factor? And so, that consortia seems to be showing up and showing off there too. So
I think you're exactly right about that. Like, let's look over here. Nitrogen is probably not your limiting factor over here. Look at Invita. Now that's trying to solve a nitrogen problem. If that's not your limiting factor, your bushels of corn per pound of nitrogen is identical because that wasn't limiting. But I think we can play around with that with biology, and that's going to sort of be the magic of it, is how can you even break that mold where now you're being even more efficient so that you can get even more bushels of corn per pound of nitrogen, even under what you thought was a full contingent of nitrogen. And it probably is. And it looks even better when you do have a limiting factor. Now we do see the Invita is starting to help. So does this other foliar, but wow, really get the biology working, it helps even more if the nitrogen is the limiting factor. All right, I'm gonna close right there and answer any questions that you guys might have. Let me stop sharing. I can turn my camera on again too. So if you guys have any questions, I'm happy to answer them. I think biology is very new, and we're working on how do we use this in a way that it helps our growers. We have credibility. We're giving great recommendations and helping the industry as a whole. And I think we're learning.
Yep. Jared, do you have a question?
Yes, sir, Robin. Talking about right there at the end about whether or not nitrogen was a limiting factor or not. If we're harvesting these results and we see that we're coming up with virtually the same thing, could we pull a soil test like right there, right after the combine to determine if there was still nitrogen in the soil and if that was a limiting factor? Would that be the best way of possibly going about that? Or what, if we're suspecting that N is not the limiting factor, how would you go about confirming or authenticating that?
I think it's going to be complex because you could pull a soil sample and see, are you low? That would be a very direct way to do it. Sometimes you can have nitrogen there, though, and actually getting it into the plant is the limiting factor. It's there, but if you can improve root growth, if you can improve general vigor of that crop, or even things you can't see, like the microbes that might be pulling that in, I think you'll miss that by simply taking a soil test. But I think it's a great start. Limiting factors can be very complex. It could be nitrogen. It could be general vigor. How fast did it come out of the ground? It could be how well did that pollinate, and even being off by a day. It could be any number of things. So sorry, I'm being a bit hedgy, but I think that's a good way to at least address that on the surface, and we'll learn more.
Good deal. Yeah, and that we have a piece of technology that we've been using here over the last year that is a handheld scanner that gives you the ability to do the scanning in the field and be able to take leaf tissue samples right there in the field and be able to look at what those levels are over the growth cycle of that whole plant. And so on the corn and bean side, so it gives you the ability to know within 5 minutes where it is. You don't have to destroy the plant. And so one of those things that gives us another tool to be able to apply the technology effectively in the right place, in the right amount at the right time, right? And so we want to be good stewards of that. How do you see the biology that we're working with affecting the nutrient use efficiency piece? You kind of touched on it a little bit in there, but where do you see the biologies as we move forward on the nutrient use efficiency side?
I think nutrient use efficiency is going to be a complex topic. What makes a crop actually take that nitrogen, move it around, turn it into yield, and turn that into yield? It's a lot bigger story than just, is the nitrogen there? It is going to relate to root growth. Your low mutec may be playing into improving root growth, and that right there improves use efficiency. It gets in there. Managing stress, even managing other kinds of nutrients, all plays into nutrient use efficiency. So it's so complicated that when people just come out there and give you some glib little answer, I don't think it lands on it, because it has many aspects that cause the crop to use all that fertility and come up with the best possible yield. May the smartest win. may the thinkers win, because this is going to be a separating the wheat from the chaff as to how this is approached.
It's a journey, right? It's not a destination, it's a journey. So
Yeah.
that, we see this as a tool in the tool chest, right, that we can go use. We've had we've had some companies come in the past that have talked about that this will be the answer to all of your problems, and I laugh at that because we're still trying to define what the problems are effectively. So to be able to use this and use this technology, and this is one of the pieces. And whenever you talk about the consortia and the way you described it as being in that, do you see that there are some in the early stages of your research, are you seeing some that work better together overall as family groups than others? And depending on crop, obviously we're heavy corn bean here on this call, a little bit of wheat, you get a little bit of cotton when you get down south. And so those, are you seeing some things like that with your early research or not?
If you're talking about like what kinds of microbes like to be friends, who wants to live together that supports each other, it's almost like humans. We should not live all alone. We have friends and family and people that support us. It usually, I think, plays into there's one or a few that are the workhorse. They're the ones that are doing the thing you want, like fixing nitrogen. There's others, though, that are making that nitrogen available, like they're composters. They just break down stuff. They're breaking down organic matter and things like that. There may be others that are signaling root growth to help get that nitrogen picked up. And even there's some microbes that are there and grow, and then the other microbes actually eat them. They're kind of a sacrificial microbe that can be a food source or produces some kind of exudate that the other microbes want to be around and want to eat. So that's the kinds of microbes that like to live together. Some of it starts to get to, well, what kind of crop do they like to live on? We know that there's some microbes that they like to live on a legume, and they'll even fix nitrogen and make nodules on a legume. Other kinds of microbes, those same microbes are not going to be as happy on corn, and they're not going to be as happy on cotton. So there are differences in who wants to live where. What kind of house do they want to live in?
Sure.
And that's, now we're back to how complex this thing is. This is
Yep.
I want to go back to your point about, can you use technology to measure nitrogen in the leaves, and is that a useful way to do it? I truly think it is, and I think newer technology is needed. I could